All right. Hello. Good morning, everybody. Or good morning, good evening, wherever you are. So today we have the Rust Gamedev Meetup. I'm coming at you live from QSEC 2023, and so this is a conference that's happening in Montreal. And so there's gonna be some interesting stuff. So first of all, I'm not sure if there's any background noise. I'm also not sure if my Wi-Fi signal is going to be good enough. So I'm gonna look on YouTube for a second here. Okay, it's mediocre. And also you have to listen to my headphone mics and they're not the greatest, but welcome everybody. So this month we have a few different people who are going to be showing off some projects. And so like last month, I changed over the registration to a GitHub issue so we could hopefully have a little bit more transparency. I also did like a little bit of a trick here where I just kind of pinged everybody who has stuff in the newsletter. So hopefully we're going to be getting some new people out. I'm hoping to do this next month as well. And I think it's awesome because there's just so much stuff that's going on in the game dev ecosystem. And so kind of having new people out to show off what's going on should be pretty cool. So a few other things I want to mention before we get started here. So right now, the newsletter for December 2022 is not out just yet. And so the issue is still up. If you have something that you want to add, I imagine over the next few days, the issue will be merged and put out. And so if there's just any last minute things that you want to get added, and you can do that. I also want to mention that in 2 weeks time from today, so that's the 28th of January, there is the Rust Graphics Meetup that will be happening. And so this will be an opportunity to see what is going on in the Rust graphics ecosystem. And so we have some pretty cool talks lined up. I'm definitely like super excited for this. It's always fun to have the graphics meetup. Have some more formal talks as well. And so we have a few different speakers. I'll be putting it together into a sort of like list of what's going on, and then reaching out and advertising this. And so that will be happening again in 2 weeks. So on the 28th at 1600 GMT. Yeah, and so, and then another thing, okay, my friend got me this, one second, let me just watch my camera here. My friend got me this like little, one sec, Ferris here, yes, okay, there we go, yes. And so she got it for me at this conference, and I do not have a Ferris plushie yet, and so I'm very happy to have gotten one here. So let me just change back over here and make sure there's anything else I wanted to go with. I think we are good. So we're going to get started with today's schedule. We have 3 different presentations. And so we have Quark here to talk about RS4. We have Indy who's going to be talking to us about digital extinction. And Kevin at the end will be talking us to updates on Graphite. And so we will get started here. We'll be back just in a minute with RS4. All right. Hello, Kevin. So, I'm sorry, not Kevin. Oh my gosh. Hello, Quark. Good morning, and welcome back to the Game Dev Meetup. And so, I don't know too much about this project yet. So, do you want to just get started?
Yes. Hello, everybody. This is a very unusual talk. I'm going to talk about ray tracing in just a bit. The thing is, this paper that I'm looking at right now from NVIDIA was released just a few years ago, and it opened a way for graphics applications and games to use ray tracing in real time. And that's something that has been debated for a while, and many people think it's just decades ahead of us. But I believe this paper is what opens the doors right now for ray tracing to be in games. We can do real time now, basically. So the future of this new generation of games depends on how well the developers can understand what NVIDIA developed in this paper. And I thought, I looked at it quite a bit, and there's a lot of math involved. There's some corners that are cut, and between the paper, which has a lot of math, and their demo source code, which is fairly complicated, even the minimal example is very complicated, there's a huge gap, which makes understanding this technology hard. So I felt that this gap needs to be filled, and I came up with something that would be extremely simple, but would give you the basics of how this works. So how this works, this is the project. Let's actually start it. It's a very small tech demo aimed at education, basically. So what is happening here is that on the left, you see the world, and we are evaluating the lighting on the bottom line, on the ground. You can see there's a splashes of white, which is where there's more light coming than usual. And at the bottom, there's a histogram of the brightness for each point on the ground. So the area under the bar, and you can see the sun on the top. So under the bar receives way less light, as expected. Still receives some light, because we're not, in this demo, we are not tracing rays just towards the sun. We consider the whole environment to be a light source, and the point with a star is just where there is a peak intensity coming in. So you can see it's very noisy. What it's doing right now is that for each point, it produces a random ray. It spawns a random ray, it sends it over, and if it happens to hit the sun, it gets the intensity high. Otherwise, it gets the intensity low. And we are trying to remember where we hit last time as well. So we are important sampling the initial samples. And then you can sort of gradually enable features that are described in this paper. The paper is called Spatiotemporal Reservoir Resampling. So our RSVOR is short of reservoir. And the educational demo is meant to help you understand how reservoirs works. The general thing about them is that whenever you need to evaluate any kind of an integral that is too hard, the general approach is that you do importance sampling to sample some of the values in this integral and then estimate it. But to do sampling, you need to know where you sampled last time, where it's good to sample, where it's not good to sample. So this is what this primitive, the reservoir, gives you. And the article describes how you can use this for checking the previous frame and checking the neighbors of the position in the previous frame. So here we can play with it, like we can increase the number of samples that we do every frame. And now it's 10. You can see the standard deviation of the brightness reduced significantly, and the noise of the brightness, you can see it also reduced significantly. But we can also enable the temporal resampling that the article describes. It decreases significantly. You can still see a lot of waving up and down, but it's much better. And if you enable the spatial resampling, it's practically smooth. The only thing that you can do better is changing the algorithm parameters, which this demo shows 4 different ways to converge. So this is the precise one. The precise checks the visibility of the samples on every sample that it uses. Well, non-precise just tries to cut the corner and only check it at specific points, like at the end of the resampling, or once after the initial sample and one after at the end. You can also move the sun and see how the lighting reacts. So again, this is the simple demo. It implements the basic reservoir spatial temporal resampling on CPU in Rust, in code that you can actually look at. There is not much code here. So this is the logic of reservoirs, just 150 lines, is absolutely nothing. And this is the demo, which mostly deals with console and stuff, and maybe 200 lines of code for the logic. And it shows you how to do resampling, how to properly ray trace in real time. So absolutely the same technology can be then used in your shaders for ray tracing. And if you have the hardware, you can actually try building something. And I assure you, it's very much real time. So yes, this is the educational demo. I'm happy to help if people have issues with it. And I'm looking forward to see more ray tracing games. I think, as far as I'm aware, there is no game that uses this technology just yet. It's still very new. The article is a couple of years old, and maybe it's mostly understood within NVIDIA itself. So NVIDIA is trying to help CD Projekt Red to integrate this technology and then release it in the Cyberpunk, but they are going to limit it to the latest generation of GPUs. It's completely unnecessary. The technology is good enough that it can be used even on the like GTX 2000 and 1000. And of course, this demo is not complete. It can be improved in many, many ways, but it does show the basics, and it's really small. So hopefully you can understand it. That's everything.
All right. Yeah, this is quite interesting. And so you showed off that the logic for this is quite small. It's only like 100 lines and stuff like that. I'm sort of curious, with that much code, how complex is it? Like, is there like a lot of magic happening in like some mathematical way, or is it relatively understandable?
There is no heavy math as seen in the code. Like this
Yeah.
is the math. It's just a few linear equations. There's absolutely nothing to be concerned. The math, the complexity of the math happens on the paper before you write down these equations. This is what is most important to understand about Rasteer. And when you try to understand it, just looking at the paper is not enough. It's not comprehensive, and you need something to run, basically, to play with it. And if you try to run their minimal sample, it's very big and it has a lot of things going on.
Yeah, okay. And I think, yeah, it's definitely really exciting to hear that you have like the ability to run this on like maybe less powerful graphics cards. But is there sort of like a limit? Like if I'm not mistaken, the 20 series of NVIDIA graphics cards still does have RTX cores, if I'm not mistaken.
Right, but yes, 20 series can definitely run it in real time. I'm sure you can build a 1080p game running with real time, which looks way better than anything today.
Okay. This is really interesting. Now, and just so I understand correctly, this demo that you have here, so you have sort of like this world that's showing stuff off. It's doing just the calculations in 2D, right? Like it's not like doing
Yes.
something similar. Okay, okay.
Yes, the spatial resampling is just taking the neighbor points on the left and on the right, and the world is basically a grid as you see it on the console.
Okay. Yeah, I quite like this type of demo. It is kind of cool how I think this is using 2E to kind of just show off like the different pieces of information about this technique. And so I'm definitely like kind of interested in trying to implement some of this for some things that I do as well. I haven't really thought about doing like an educational set type of 2E, so this is pretty cool. Yeah. All right. I don't think I see any questions in chat about this, so I think we're good to hop over to the next one. So yes, Clark, thank you so much for showing this off, and hopefully we'll see you in the future.
Thank you.
All right. So we are back. We're going to be hearing about digital extinction from Indy. I'll hand it over.
Hello. Do you hear me well?
Yes, all good.
Yeah. So I will do a quick presentation of the game I've been working on recently, or in the last 9 months or so. So basically, most of the information you can get online is inside its GitHub repository here. It also has a website, but it looks pretty dumb. It looks like this. So I would say patches are welcome and like a better design to the website. Currently, I'm focusing mostly on bringing the game to a state where you can actually play that. So I'll show you a quick demo shortly. Currently, it's still not an end-to-end game. So you can open it, you can play that, but there's like not a win condition. There is some pieces missing. So this is how it looks like. So there's a simple main menu. Multiplayer is not yet implemented, so you have to open a single player game. You can choose one of the two maps. These are pretty simple maps which I use mostly for testing, and then the game looks like this. So basically, this is what's already implemented. So some camera movement, unit selection, health bars, and so on. And yeah, some simple attacking like this. And that's pretty much what the game can do. You can destroy an enemy unit. There's some pathfinding, obstacle avoidance, and so on. And yeah, that's it. That's what the game can do at this point. So what I'm trying to do, as I said, I'm trying to implement a game which is featureful in the sense of you being able to like play against somebody online, being able to win or lose, but the functionality will be very minimal. On the repository, I try to put together the goals of the game, what I want to do, and some roadmap, what's being done. But what, what's the motivation why I even started working on a game like this? So when you search for open source games, you find out that there's only a few games which look modern, which look good, and which you would play for fun compared to the commercial games. And the most famous ones actually started as commercial games whose source code were released later when it didn't turn out so well. So I wanted to start a game which is developed as open source from scratch and which is not bounded by the design constraints of commercial game development. Yeah, so that's that. And I'm still the only developer on the game, so there have been a few contributions from other people, but so far, like great majority of the source code is made by me. It's based on the Beve engine, and it's licensed under GPL version 3 license. And the tag-wise, it's implemented as a big list of small crates, each implementing a single Beve plugin group. So I'm trying to break down the game into smaller pieces to make it easier for newcomers to contribute without the overall knowledge of the full architecture, the full source codes of the game. So that's it. That's all from me.
Perfect. This is super cool. When I was in like one of my game dev courses, we implemented an RTS for I think it was like in Unity or something like that. But I did get to see a lot of like the, sort of like the intricacies that you have to consider. And so, I mean, one of the things I really enjoyed was like the animation of like the attack between the two units. I think that one's pretty cool to see. And what I'm curious about is like with some of like the character animations and like the attacking animations and stuff like this. How did you find it like implementing it through Bevy? And do you find that there were any like either restrictions or difficulties as you were going along?
Yeah, what I've discovered the hard way is that it's pretty tough to like develop everything myself. So I'm cutting corners here and there. For example, one of the very difficult problems is actually like movement and pathfinding. So what I try to do is to make the movement completely free, so there's no tile grid, nothing like that. So any unit can be at any floating point position on the map, and the path finding is done through a modification of so-called nav mesh. So basically, I break down the surface of the map into triangles, and then I search in the graph of triangles. But then on top of that, you have to do something like um, dynamic obstacle avoidance. So there are like obstacles which are moving constantly, so you cannot, from the performance point of view, consider them inside the global pathfinding algorithm. So you have to like do some uh, tricks to be able to calculate all of that at 60 FPS or something like that. So that's pretty tough. And maybe I'm bad at searching, but there's like very little information on how to do this stuff outside of trivial solutions which are outdated by now. So oftentimes there are algorithms, but I can see that these are good for games during in the 90s, but to make it modern, it's hard. It's all proprietary, and there's very little information out there. So I'm taking inspirations in other fields for other fields. For example, the obstacle avoidance algorithm, which I'm like currently working on, it's inspired by papers from robotics. And yeah, it's hard. Sometimes I have to come up with stuff myself, and this is my first big experience with game development. So yeah, I might choose bad solutions and discover like very late, and then have to rewrite a lot.
Yeah, that's very true, and I think that's a great point where when you're doing a lot of this type of stuff, there needs to be like either algorithms that you can source and you can like make use of, but depending on other maybe constraints or restrictions you've put on yourself with like the scale of what you're trying to do, maybe these algorithms don't work, and so yeah, I think it's very difficult, but maybe it's also exciting, like that you get to like try to do some of this exploration. Um, and sort of on that topic, I did see in single player you had a button that was like 1,000 units, and so I was curious as to what that was. If it was like just like a simulation or what was that?
Yeah, so I'll start that. I'll show you. Basically, it's a dump map which I use only for testing of the performance. So the idea is
Hmm.
that there will be up to 4, maybe 8 players. That's not decided yet, and each of the player would have a limit of 1024 moving units. So I wanted the game to scale to such an extent, and basically the map looks like that. What you see here, these are supposed to be drones, but I'm using the Susanna monkey from Blender for that.
Nice,
So
nice.
yeah, uh, on top of the development itself, I discovered that I don't have enough capacity to do even the modeling myself. So I hope that somebody will like join me soon and help with the 3D models, textures, and so on. Yeah, it looks like that, and yeah, you can do stuff like like move.
That's so cool.
Yeah, and it all works on like 60 FPS right now. But again,
Yeah.
for example, I know already about some big improvements to the pathfinding algorithms which I would like to do, but I'm not focusing on that right now since I want to like basically finish everything to a state where it's good enough so you can actually play it. And once that's done, I will like start focusing on improving that so it's like smoother or better.
Hmm. Yeah, yeah, absolutely. One question from chat. This resembles a Warzone 2100 early state prototype. Have you heard of that game before?
Yeah, yeah. And when I was talking about the open source games, this is like one of the most famous one of the most famous open source 3D strategy, but it's like over 2 decades old already. And
Hmm.
there's lots of development, but it seems that it's like the game played 10 years ago and now it looks the same. So it feels like
Hmm.
there's like maybe some tech improvements under the hood, maybe uh, yeah, it gets some polish, but it doesn't feel that it's progressing like forward that much. And also, it's if I'm not mistaken, it was started as a commercial game and open source only later. So I wanted to change that and like do a modern game which is like developed as an open source game from scratch. and I'm very dedicated to that goal. So I have no plan on quitting on that, and I understand that I have to take it pretty far before the community notices and I start to get contributions from others. So yeah, there's still a lot of work which I have to do until it starts to look good, and people actually take it seriously to contribute their time and energy into it.
And finally, one more question. I'm a big fan of Warcraft 3, and I really love like the custom maps that were made back in the day. And so, for like what you're creating, do you have any thoughts on like what a mod system, a plugin system, a custom map system could look like, or is that something that you're sort of waiting until far off in the future?
Yeah, so I have some ideas, and inside the repository there is there's issues if for anyone who's curious, but this is like concrete things which I want to happen like in the near term. But then there's like discussions, and whenever I have like an idea, I open a discussion so others can comment, and I can get to it later when when the game is more mature. So I don't want to think that much about this, since I want to be like laser focused on like doing the very minimum to like make the game playable, because I don't want to do the mistake that I will like spend months, maybe years on like some feature, and then the game will be never finished because there will be like important fundamental pieces.
Absolutely. And I think I really like this idea where you have sort of this living design document of using GitHub discussions so that you can go in, kind of put an idea down there, have people potentially discuss it in the future, but have it completely in the open. So yeah, I think this is very cool to see. And I might come check some of this out because I do like thinking game design. And it looks like there's a lot of game design to think about. Yeah, okay, awesome. Well, Indy, thank you so much for showing this off. I definitely hope to see this in future months because it looks like there's a lot of potential for progress coming potentially soon. So, yeah, thank you very much.
Yeah, thank you, do.
All right, hello, everybody. We are back with the final talk for today. We're going to be hearing from Kevin about some updates to Graphite.
Yes, first of all, testing my audio.
Sounds good.
Okay, awesome. So, to begin for this month of Graphite progress, and first of all, if you're just tuning in for the first time, if you're wondering what Graphite is, we are building a open source 2D graphics editor, mostly in Rust. Besides the front end, which is sort of temporary, we're building that in web technologies, but eventually we'd like to port that to Rust as well. But at the moment, basically the idea for Graphite is to make kind of the ultimate 2D graphics editor. And just like how Blender is kind of the ultimate 3D graphics editor, we really want to become the 2D counterpart to that. And by basically starting out with making an application that works with both raster and vector, that way you don't have to have two separate pieces of software to do the same kinds of graphics editing that you would normally do if you wanted to do graphic design or vector illustration, and then have to import some of that artwork, that vector artwork, into a raster editor. There's no reason to have those in separate products besides artificial product segmentation. So we want to put them all in one product. And then also we want to additionally bring together the concept of a node graph that's very popular in game development and bring that to 2D, because that really, really would help with making a non-destructive workflow that works really well for 2D editing in the same way that we've seen that works really well for 3D editing. So here's a quick overview of the future graphics, the future UI for the product. And there's a few things that are temporary here, like the layer tree is going to be hopefully made clearer, but besides that, that's kind of what it's going to look like in the future. And it doesn't actually look that different from it at the moment, but we just have vector editing at the moment rather than raster in the future as well. We do have a little bit of raster, and I'll show a little bit of that, but we're working towards making it a full-on raster editor soon. So, the progress from Sprint 21. That's been this past month of mostly December, but a little bit of this month as well. And starting out with the node graph quality of life upgrades and the backend progress. So last month, we actually basically just introduced the node graph for the first time. And this month, we have now been working on improving its quality of life. So what that means is that you can basically use a lot more buttons and features to make it so you can more easily connect up links between nodes, and I'll show off a few of those in a minute. Additionally, Imaginate, which if you have tuned into previous months, you will have seen Imaginate is basically an integration of Stable Diffusion to do image generation and image manipulation through the power of AI image synthesis. And basically, you can take an existing image, and that's what makes the node-based approach now very powerful, is that you can link together nodes between Imaginate generations and basically work sequentially, making changes to one generation and then using that as the input for another generation. Additionally, you can branch off the nodes and essentially have the creative freedom to try out many different directions and use whichever branch is actually the one that looks most useful to you. Additionally, this month, we were working on a port from Vue to Svelte. This is our front-end framework, and this should hopefully bring improvements to performance and also improvements to our TypeScript experience so that it makes it easier to work with, hopefully removing the number of bugs, because static type checking is really good, and the more support you have with your framework, the fewer bugs you have in the front end. That still has a few bugs during the port, but hopefully that should be fixed in the next few days, and we might actually be able to fully switch over from Vue to Svelte very soon. Additionally, we have worked very, very hard this past month and basically polished the heck out of this thing. We've done literally dozens, many dozens of basically bug fixes, as well as improving paper cuts and some of the biggest problems that we've had, like, for example, the undo system, which was really janky in the past. That has now been mostly fixed, essentially fixed. So now it's much easier to use Graphite, and hopefully when we launch next month, hopefully at this meetup next month, we will be having an editor that is much nicer to use for people who are just tuning in for the first time, when they'll perhaps run across it on Reddit or any of the other places that we end up announcing the product for. So without further ado, let's show off some of these changes. We have here a piece of artwork that I made. I also made a time lapse, so I'm not going to play the full thing, but I will actually speed this up to 2x speed, and here it is at 1.5 times. Sorry, here it is at, I guess, 50x speed now, effectively. But this is just showing a vector editing workflow, and I think I'll just skip ahead a little bit. The full video, if you want to watch it at a little bit more of a sane speed, is available if you search for, I guess, the title of the video that you can see in the top left, or if you check out the newsletter that's coming out in the next few days, and there's a link to this in that as well. And then here is the usage of generating, using Stable Diffusion and the Imaginate feature, generating a backdrop for this vector art, which is a really powerful way to sort of frame your artwork with something that gives it a little bit of context in its background. So kind of like a deep sea texture sort of look. And you can see that is now how you can color grade it as well. And yes, so showing off some of the node-based editing here. This is the first Imaginate generation. So you can see that we started out with deep sea gradient backdrop, matte painting, underwater, many small bubbles with increased basically increasing many small bubbles importance to 1.3. And also vector art also increasing its importance by 1.3. And then we're telling it to remove anything called clip art or the color pink or watermarked or watermark or pattern, removing any of those, and telling it to add these keywords. And it generated, and here's one of the quality of life improvements. You can click on this node and then hit preview. And what that does is it tells it to preview the output and basically make it so the output is this node rather than the output node that you're seeing. So you can see we had bubbles, and I didn't want those big bubbles because they were a little distracting. We are underwater, of course, but those bubbles were a little too big. So I fed that one into another Imaginate node, and you can see this is the input here. And if I preview the output of this one now, you can see I masked out those bubbles. So if you actually scroll down here, and you see that the masking layer applied is this folder, and that folder is this folder here. And we actually have it hidden at the moment, but I can basically unhide that briefly, and you can see these bubbles cover up the original bubbles. So I masked them out, and I additionally I removed the negative prompt because it wasn't necessary at this point. I simplified some of the prompt as well, and basically just said deep sea backdrop, matte painting, underwater, vector art. And then I generated this version. So it went from, actually I'll hide the character as well, and you can see it went from this one to, and I can also alt click, and that changes the preview. So I don't have to click here and then click preview. I can actually just alt click. And then additionally, one thing you can do is you can also hide nodes. So this is one of the quality of life improvements. Here is the hue/saturation. So if I preview that, you can see it darkens it and makes it a little bit less saturated. And now, if I wanted to show what it's like to hide a node, what this does is it basically bypasses that node so the data comes through. And what's happening, as you can see, is you start with the Imaginate node, then you bypass this one, and then you do the hue and saturation. So you can see basically we have the same hue and saturation effect applied, but we don't have the second Imaginate generation that removes these bubbles. And of course I can unhide it by hitting show, and now we have that back. And of course we can just go and re-preview the output like it's normally supposed to be, and show our character again, and that is that. So let's see, a few of the changes we were talking about. Let's see, what did we have to show? Yes, so I can give actually one more demo of using the Imaginate tool in a pipeline, basically in a node graph feeding one to the other. So I will generate, let's say, high-speed train through the countryside. And let's see how this looks. And let's try a few more ones. Here we go. So that looks decent. So what I can do here is I can go ahead and duplicate this node by copying it and then pasting it. Oop, I guess that happened twice. Whoops, I accidentally deleted the layer instead of the node. But you can always just Control-Z that now that our Control-Z system works properly. So now if you go to the Imaginate node here, and now what I'm going to say is, in a storm with lightning. And I will increase the importance of it because we want to make sure that it's able to change that blue sky into something that's really an important change. And rain. And we will see now how it changes it. We want to say adapt input image, so that way it actually takes the image, the input image from the left here of the node, and then gives it on the output to the right. So in previous months, we did not have this node-based system. So each of the Imaginate layers, there we are, we have some lightning now. Each of the Imaginate layers were actually just layers in the panel, in the node graph panel. But now they're actually nodes, which allows you to do this, where you can chain them like that. Additionally, I would like to experiment a little bit. So I'm going to duplicate this node here, and I'm going to feed it in here, and I'm going to preview it. And what I'd like to try now is I'm going to change, I can just change the seed, for example, and get a different version and see which of these I prefer. So I can toggle between that one and that one. And I think I maybe like, well, let's try one more. And maybe I can also change the text description now. Or I can change the prompt guidance. So the prompt guidance is basically how how creative it is, sort of how much it follows the text versus applying some of its own creativity to the problem. So I will show that version. And maybe I will duplicate it one more time, and then this time show, whoop, waiting for the node to duplicate. That is taking a little longer than it should. Uh-oh. I might have frozen it. Oh, speaking of freezing it, one other improvement is that we basically improved how over time the user interface would slow down and freeze, except apparently not in this case. So I will restart the editor real quick. But as you can see from what I was showing earlier, basically you can experiment with different variations, and you could even increase the length of that by saying, okay, I want to try lightning in this one, and rain in this one, and snow in the other, and see which of these you actually prefer. And you might try a few more Imaginate generations to make additional changes before you then move on to picking your favorite, or you could even export multiple and share all of the different variations. So the node-based workflow basically allows you to branch out and explore different creative directions, and that's something that's really powerful with the non-destructive approach that nodes can provide. So as we move towards other tools becoming node-based as well, basically we took the Imaginate tool and turned that into a node, but we're now going to be working towards, in the next few months, moving all of the existing features you see. So for example, the text tool, as well as all the geometry for these vector tools, all of those are going to become node-based, and eventually everything will become a node. And then we're going to remove the concept of separate layers, and then all of the layers are actually going to become part of the node graph. So your node graph is actually your entire document. And then inside of your document, you will then have multiple nodes that are actually layers. So each of these layers are going to end up being part of one node graph. And that is basically our next big progress, our next big project, as we move towards progressing and ultimately releasing Alpha Milestone 3. But in the meantime, next month we are going to be releasing Alpha Milestone 2, and that will be basically the culmination of a year's worth of work, working towards basically improving everything, adding a node graph, and making it so it's basically a usable piece of vector editing software. So if anyone wants to do any artwork that's vector artwork and they want to use a web-based editor, although in the future we will have a more proper desktop editor as well, this is hopefully the tool for people now. So yes. And yeah, so please do get involved. Join our Discord server and basically just try out the editor, show off some of your artwork, ask questions, see how see what you might be able to do, either make as a piece of artwork or make if you want to join the team and basically take some of the issues. We have a nicely curated bug/issue board, and there are a lot of bugs, a lot of features that you can basically just pick up and get rolling. So please join our Discord server, and please check it out on GitHub to see what kind of issues you might be able to work on. Thank you.
Awesome. I definitely like this move towards having everything in the node graph. I think that's sort of like a step that I wouldn't have expected from the outside, but if you have a lot of properties that you can sort of enforce with that, it's pretty cool to see.
Yes, that is kind of everything just sort of falls into place once it's all node-based. And we're currently having to work around some of our issues. Like some of the features are a little bit janky at the moment, like the user experience isn't perfect, and that's just because we're waiting until it can become node-based, because everything will become a lot simpler and easier to implement, and also just more consistent from a user experience standpoint once it's all node-based. Because, for example, if you want to pick the mask for an Imaginate layer, right now you have to reference another layer, but instead, in the future, you'll just be able to drag that in as an input to the node graph. And the reason we can't do that yet is because even though the Imaginate tool is now a node, the actual vector shapes are not nodes, and we have to render those separately and bring those in by referencing it as a layer. But pretty soon we'll be able to then basically import those in the same node graph rather than having to actually reference it to another layer.
Yeah, okay. I think I see what you mean by that. And as well, just out of curiosity, with the move from Vue to Svelte, are you able to sort of take this time to reorganize how some of the front end is done, and then maybe get some better ideas on like what a final version of the UI could look like?
Yeah, so partially we wanted to be very, very constrained in the port and basically exactly change the code between languages or between frameworks without making any other changes, because we wanted to make sure that we're basically reducing the surface area for bugs as much as possible, because there are, of course, many bugs that come along with changing the architecture between one framework and another that do things differently, even though they're relatively similar in terms of most of their concepts. But if you're changing, it's like 10,000 or maybe 8,000 lines of code. There's a huge surface area there for bugs, and you really want to reduce that as much as possible so you're changing as little as you can. So that's why in this initial push, it's been an opportunity to audit the code essentially, because I got to read over all of the front end code and change it. And that means I've learned some of the things that might need to change in the future, as well as fixing some bugs that we actually encountered along the way, because now it supports better TypeScript support, better type checking with the components that we're using, and that has actually identified a handful of bugs that actually existed in the previous editor with Vue, and that allows us to make those improvements. And then it also frees us to work more on larger front end changes as we progress with additional development, not feeling like we're going to increase the size of the front end too much. And we were wanting to do this port for a while to Svelte because Vue wasn't really meeting our needs with TypeScript support. So now we're a little bit less constrained, and we can start adding more changes to the front end, with basically increasing the size of its code without ultimately increasing the amount of work that goes on to a future front end framework port. Of course, we do eventually plan to port from Svelte to something that is purely Rust based, hopefully Xylem once that comes around in a few years. But it will be a little bit of time before we're really ready to do that, because the front-end framework world has to improve in the Rust world. Yeah, in the land of Rust frameworks, the many, but not ever too mature frameworks in the Rust world, yes.
Absolutely, absolutely. All right, yeah, it's great to see the updates, and I'm definitely excited to see what Alpha 2 brings next month. So thank you very much, Kevin, and I
Very
guess we'll catch you next
exciting
time.
to be able to release that next month, so stay tuned.
Perfect. See you then. All right, so that is it for today's meetup. Just as yet another reminder, we do have the Rust Graphics meetup coming in 2 weeks. So that's 2 Saturdays from now. And so that's going to be super exciting. And yeah, that's about it for today. So we'll call it here, and we will see everybody next month.